Today we'll see what is a number system and how to represent a number. So here, before going to represent a number, first we need to know how to define the number system. So the definition of the number system is like this, like defined as an ordered set of symbols known as digits with well-defined rules to perform certain arithmetical operations. That means whatever the number system we are concerned with, in that number system, whatever the numbers you are having, they are called as an ordered set of symbols with some defined rules. So these rules, based on these rules only, you can do the arithmetical operations. So this is how we can define a number system. So whenever we are talking about a number, the first number system which comes into our mind is a decimal number system. So before going to the decimal number system, we'll see how to represent a number. So mainly the number consists of two parts. One is the integer part, the other is the fractional part, and it is separated by a fractional point. And moreover, the digit whatever you are having in the first in your integer part, that we are calling as least significant bit, and the bit which is on the leftmost is called as most significant bit. And in the fractional part, what are the first bit you are having, that one is called as the most significant bit, and at the last right side what we call it as least significant bit. So a number is having two parts, one is integer part, the other is a fractional part, separated by a point called as fractional point. So now let us see some examples. Now the first example whatever we are having, as we are well versed with your decimal number system, I am taking an example of 124.13. so in this decimal number, so the 4 what we call it as your LSB, and here the 1 is called as your MSB, and 1 in the fractional part is called as your MSB, and 3 is your LSB, and the point which is separating two parts is called as decimal point. That means it depends upon depending upon the number system, the point name is the, for example, if it is an octal number system, the point which is separating the integer and fractional part, we are calling it as octal point. If it is a binary number system, we are calling it as a binary point, and if it is a hexadecimal number system, we are calling it as an hexadecimal point. Now we'll see, before going to the all other number systems, first of all we have given some information in representing a number in at the bottom of the number, that what we call it as your base, is the base of your number. So what exactly a radix or base of a particular number system? So the radix or base is the total number of digits present in that particular number system are represented by small r. So what we are doing here, the total number of digits which are present in a particular number system is represented by the base of that particular number system, that is called as a base of that particular number system. Now you can see here, so I am showing the base on the one column and the number of digits which are there in the set that I am showing the other column. Now if I take the base as 2, then we are calling it as binary number system, and it is having two digits 0 and 1. If it is a 3 as your base, that is r is equals 3, that is ternary number system, it is having 0 1 2. Likewise 4, the base is 4, the characters in that set we have 0 1 2 3, and if it is 5, 0 1 2 3 4. And coming to your 8, base 8, what we have said, it is octal number system, base 8 is having a base 8, so it is octal. And our decimal number system is having the number 0 to 9, and hexadecimal number system is having 0 to 9, and after 9 we don't have 10 and etc. So whatever the next numbers what we have, that we are representing as A, B, C, D, E, F. So the total digits, alphabets as well as numerics, whatever we are having here is total is 16. Here in decimal number we have 10, and octal number system we have 8, and in your binary number system we have 2. So the total number of digits which are present in that particular number system, we are representing it as its base. Now for each and every number system we have some positional values. What are these positional values? Let us see. The positional values represent the position of that particular bit in the number system. So how we are defining the positional number system means, so we are going to represent the position of that particular bit in that particular number system. The best example what we have here is the decimal number system, as we are well versed with the decimal number system. Now I am taking the example like 234.10 base 10 is my number. So now what you have here is 4 is having a position as your units. This is your tens position, and this is your hundreds. 100, 10 and a units position, that we call it as 10 power 0. And coming to the fractional part, the first part what we have is 10 power minus 1, and the second number you are having 10 power minus 2. So these values, when it is multiplied with the concerned number, then it will give the weight of that particular number. Now how you are getting 234? That means that is 2 into 100 plus 3 into 10 plus 4 into 10 power 0. So that gives 200 plus 30 plus 4, which is equals to 234. So the positional values are nothing but the weight of that particular position. So here what we have is decimal number system is having the positions of 10 power 0, 10 power 1, 10 power 2, 10 power 3, etc. And fractional part 10 power minus 1, 10 power minus 2, 10 power minus 3, so on. And coming to your binary, it is having 2 power 0, 2 power 1, 2 power 2, 2 power 3, and 2 power minus 1, 2 power minus 2, so on. For octal number system, you are having same 8 power 0, 8 power 1, 8 power 2, 8 power 3, and 8 power minus 1, 8 power minus 2, and so on. For your hexadecimal number system, that is 16 power 0, 16 power 1, and so on. And here 16 power minus 1, 16 power minus 2, and so on. So now on the whole, what I can say here is, so whenever I am talking about the positional values, the main thing which is coming into the system is, that is the base or the radix. So whenever we are having the knowledge about my base, then automatically I can find out the positional values. So the positional values are nothing but the power of that particular base. So this is how we can know the minimum basics about a number. So a number is always represented with the two parts. One is the integer part, the other is the fractional part. So it is having an LSB and MSB for integer and fractional part. So always it is represented with a base. So I have given the example of a decimal number system. Then the positional values are nothing but the powers or the weight of that particular position which is given.